Hi, Thursday, day 141. Looking at waves and wave properties, and just trying to explore waves and see how we can make them behave differently. So we're going to use a sim today. If you have some stuff that you can use in the house to make waves, then you can use that too, and I'll give you some ideas for how to do that. So first thing for the warm up, it's time for flipping physics. That's right, Mr. P's back. We've got a video on waves, specifically mechanical waves, so you learn what those are, and some lecture notes. Video is pretty cool. He shows some different types of waves, like transverse and longitudinal. This is a transverse wave down here. This is a longitudinal wave there. And if you haven't watched this yet, go ahead and start it.
Good morning. Let's learn about waves together, shall we? Yes.
Wonderful.
Thank you very much for learning with me today. I enjoyed learning with you.
Okay, cool. Hope you enjoyed that video. And let's go over the answers to the warm-up. So if you didn't answer these yet, go ahead and pause and do that. And let's go over number 2. Okay. So, 5 examples of waves. So in the video, he gives some examples. The sound that you're hearing, my voice, the light that you see with your eyes, the electromagnetic radiation that gets the signal from, say, the router over to this device, right, or the cellular signal that's getting it to your phone. Water waves, and I believe he says one other one. So let's see. So which of these require a medium? Well, so a medium is something that that the wave travels through, and of these two types, mechanical and electromagnetic, the one that requires touching is mechanical. Electromagnetic waves are cool because they don't require any kind of medium. That's why they can go through space. That's why light can get from the sun to us, even though there's basically nothing out there in space. It's kind of a special trick. So that's what a medium is. For the spring, it's metal. For the wave and the spring, you could consider it to be metal or the spring. The sound. What's the medium that's getting the sound from your phone to your ears? What's in between the speaker and here? Feel it? It's this stuff right in here. What's there? Air. It's air. Air molecules. Each one bumps into the next, and eventually they bump into one that's next to your a bone in your ear, and it vibrates the bone, and then your brain recognizes those signals, and that's how you hear stuff. It's pretty cool. Transverse waves. So, which direction would you move your hand to make a transverse wave? Would you go up and down like this, and then the wave goes off like that? Or would you move back and forth this way, and then the wave moves like that? And then the same question for longitudinal waves. Somebody found the wave machine. Eh? All right. Moving on from there. You're going to play with a simulator today. You can make waves on your own using household things, but it's kind of hard, and everything that we have in the house has lots of friction. So making waves that are perfect is really hard. You want to say hi? Say hi. Okay.
Hi.
Good job. Hi, Jackson. It's really hard. So it's actually a lot easier to use a simulator than it is to do the real thing. So with that in mind, there's a lot of instructions here. They're pretty specific. Let's just go over the first one where you use waves on a string. You're going to have the oscillate button on, no end checked, and slow motion. And then you're just going to adjust things with amplitude and see what happens. Oh, hey, buddy. You got to pause for a second. That's loud. All right. So when you get here, it'll just be sitting there like that. Oh, you want to help me start it? Okay, hang on. Hang on. So here's amplitude. I've got no end selected, oscillate selected, which means this is just going to go up and down. It's going to be basically like your hand moving up and down.
You want to start it?
Yeah, you can start it. Press play. Oh, here we go. Okay, press play. Just tap it. There you. Oops, you tapped it with 2 fingers. Tap it with 1 finger. There you go. Good. Okay, and we can see our wave being created. And since it's oscillating, it'll just continue doing this forever. So I want you to play around with amplitude and see what happens. Lower the amplitude. See what you get now. All right. Increase the amplitude. Don't mess with the other stuff. Just adjust these things. And you should be able to get an idea of what amplitude means by how changing this affects the amplitude. If you want to watch this full speed, you can. It's fine. So I want you to do that with amplitude, and then I want you to do it again, except with frequency. All right, so change the frequency, see what that does, come up with a definition for frequency. And again, sometimes being on slow motion is really helpful.
Low, high, low, high, low,
And then do that again for damping and tension. All right. So that's what this is all about. You're repeating this. So I want you to come up with a definition in your own words, not a science definition, but in your own words. Hey, Jackson. Jackson, you can't do that while I'm making the video. Thanks. All right. And yeah, so I had a string, or sorry, I had a spring on the floor when we did this in class. But obviously we can't do this year because we're not in class. So you can do this with a necklace. You can do this with, I gotta show them some stuff, buddy. So if you wanted to, if you had a wave going, all right, like that, and you wanted to increase the amplitude, what would you do with your hand? Hopefully you think you'd move it farther, right? You give it a bigger swing, and that gives you a bigger amplitude wave. I want you to think about how you would do that, or how you would adjust the frequency and damping and other things, tension as well. Okay. Later, I'm asking you to do some tracing. So that means you're going to make a wave. You're going to pause it. And it's really important to draw this on your paper. Draw this little wave generating machine, this little pump, because that'll be your home base. And then you need to trace where all the green balls are, and then hit play, and then pause and draw it again, and then play and pause and then do it again. And you can do this just by putting a piece of paper right over the screen. And then I want you to answer some questions about the green balls. See what you notice. The last thing I'm asking you to do is change the settings between fixed and loose. So going back here, we've got our wave going. Give it a fixed end. Sometimes it helps to just restart. See what you get. What's going on there? Give it a loose end. restart. See what you get there. See if you can explain what's going on. Let's see. Last thing for this graph here in number 5. Right, for the graph here in number 5, you can use the rulers to create a position time graph. Oh, you drew one? Good job. So you can turn on the ruler right here, and let's do this. And then you want to put your 0 line at the 0, and you can get a height. All right, so you can use the little slow motion single step tool to get a height right there. And then you can let it play for a little bit. You use the timer here. You can let it play. And then after a bit of time, you can get another height. A little bit more time, you can get another height. And you can see if you can see some patterns. And that's about it. All right, so today is just exploring these 4 terms: amplitude, frequency, tension, damping. Feel free to look them up if you want to get physics definitions of them. But I wanted you to try to explore using the simulator and see what they mean on your own first before you dig in and get a official definition. Okay. And that's it. We'll come back. We'll discuss this stuff a little bit more in depth tomorrow, and then get into some of this vocab of waves and some of the terms that we're going to be using for the rest of the unit. Hope you have a great Thursday.
Bye-bye.
Let me see your... What'd you draw? Hold it up. Wait, you can't see it. It's not bad, right? Kid's Picasso. All right.